Welcome to the presentation on design patterns. Today we will dive into key concepts, explore different types of design patterns, and look at practical examples to help us understand how these patterns can improve software design. Design patterns are reusable solutions to common design problems faced in software development. They provide standardized approaches for solving recurring issues. By applying these patterns, developers can improve code quality, scalability, and maintainability, ultimately making the development process more efficient. Using design patterns brings several benefits to developers. First, they improve code quality by reducing redundancy and encouraging best practices. Second, they speed up development as developers can leverage proven solutions instead of reinventing the wheel. Third, they make the code easier to maintain by promoting modularity. And finally, design patterns provide a shared vocabulary, making collaboration between team members easier. Design patterns can be categorized into three main types: creational, structural, and behavioral. Creational patterns deals with the process of object creation. Structural patterns focus on the organization of classes and objects, and behavioral patterns manage the interaction between objects. To elaborate further, creational patterns like singleton and factory method helping in managing object creation. Structural patterns such as adapter and bridge deal with the composition and relationships between objects. Lastly, behavioral patterns like strategy and observer handle object interactions and communication. Creational patterns focus on object creation. The singleton pattern ensures that a class has only one instance and provides a global point of access. The factory method defines an interface for creating objects, but it allows subclasses to decide which class to instantiate. Other creational patterns include the abstract factory, which provides an interface for creating families of related or dependent objects, and the builder pattern, which constructs complex objects step by step. The prototype pattern creates new objects by copying existing ones, saving time and resources. Structural patterns help to compose classes or objects to form larger structures. The adapter pattern converts one interface into another, while the bridge pattern separates abstraction from implementation, allowing for independent variation. The composite pattern combines objects into tree-like structures, treating both individual objects and compositions uniformly. The decorator pattern adds behavior to objects dynamically without altering their structure. The facade pattern provides a simplified interface to a complex subsystem, and the flyweight pattern reduces memory usage by sharing objects. Finally, the proxy pattern provides a surrogate or surrogate or placeholder for another object. Behavioral patterns deals with the communication and interaction between objects. The chain of responsibility pattern passes requests along a chain of handlers. The command pattern encapsulates a request as an object, allowing for parameterization of clients. The interpreter pattern defines a grammar for interpreting sentences, while the iterator pattern provides sequential access to elements in a collection. The mediator pattern reduces communication complexity between objects, while the memento pattern captures and restores an object state. The observer pattern notifies all observers when an object's state changes, The state pattern allows an object to alter its behavior when its internal state changes, and the strategy pattern defines a family of algorithms, making them interchangeable. The template method pattern defines the skeleton of an algorithm, and the visitor pattern adds operations to objects without modifying their classes. Learning design patterns is important for several reasons. They allow us to solve real world problems more effectively, and they are often a crucial topic in software engineering interviews. Additionally, many popular frameworks like Spring and Django rely heavily on design patterns, making them essential in real world applications. Let's look at a practical example of the singleton pattern. This pattern ensures a class has only one instance and provides a global access point to that instance. A common use case for singleton is in managing shared resources like a logger or a database connection. Next, let's explore the factory pattern. This pattern provides an interface for creating objects without specifying the exact class of the object. For instance, a shape factory might create different types of shapes, such as circles or squares, based on user input, abstracting away the details of object creation. To learn design patterns effectively, start by understanding the problems each pattern solves. Once you grasp the problem, move on to learning the structure of each pattern. It's essential to understand how they work before applying them in your own code. Next, practice implementing the patterns in different scenarios. Try to apply them to real world problems. Analyze how design patterns are used in popular frameworks like Spring, Django, or React to gain further insights into their practical use. Now, let's move on to some interactive exercises. First, implement a singleton pattern for a logger class. Then create a factory pattern for drawing different shapes like circles and squares. Finally, discuss real-world examples of patterns such as the observer pattern in a web browser. In conclusion, design patterns are essential tools for creating efficient and scalable software systems. By understanding and applying these patterns, we will be able to solve design problems more efficiently, write more maintainable code, and improve our collaboration with other developers. Keep practicing, and soon you will see the benefits of using design patterns in your daily work.